The limitation on the size of the conductor used to connect to a concrete encased electrode is determined by several factors. These include current carrying capacity, bonding strength, corrosion resistance, and cost. Firstly, consider current carrying capacity. The conductor must be sized to handle the maximum fault current expected to flow through the electrode. The concrete encasement offers protection against corrosion and physical damage, but it doesn't enhance the electrode's ability to carry current. Secondly, let's address bonding strength. The connection between the conductor and the electrode needs to be robust enough to withstand any forces applied over the installation's lifespan. A larger conductor offers a stronger bond, but it's not always essential. Thirdly, corrosion resistance is vital. The conductor must be made of a material resistant to corrosion, such as copper or stainless steel. Increasing conductor size increases surface area, potentially raising the risk of corrosion. Fourthly, cost plays a role. As the conductor size increases, so does its cost. In most scenarios, a number 4 AWG conductor is adequate for a concrete encased electrode. However, a larger conductor might be necessary if the fault current is unusually high or if the electrode is situated in a corrosive environment. The National Electrical Code, or NEC, outlines the specific requirements for grounding electrode conductors. Table 250.66 within the NEC provides guidance on the minimum size of grounding electrode conductors based on the size of the service entrance conductors or equivalent for separately derived systems. However, there are exceptions and specific rules that apply to concrete encased electrodes, also known as U for grounds. Section 250.66 subparagraph specifies that if the grounding electrode conductor is connected to a concrete encased electrode as described in 250.52 subparagraph point 3, that portion of the conductor that is the sole connection to the concrete encased electrode is not required to be larger than number 4 AWG copper wire. This is in accordance with 250.66 subparagraph B. Now, let's dive deeper into why this limitation exists. The primary purpose of a grounding electrode system, including a concrete encased electrode, is to provide a low impedance path for fault current to return to the source. This facilitates the quick operation of overcurrent protective devices like circuit breakers or fuses, thereby minimizing the risk of electrical shock and equipment damage. Concrete encased electrodes are considered highly effective grounding electrodes due to their large surface area in direct contact with the earth. This provides a stable and reliable ground connection. The code recognizes this effectiveness and allows for a reduced conductor size. The concrete encasement itself contributes to the overall effectiveness of the electrode. The concrete helps to maintain a consistent moisture level around the electrode, which improves its conductivity and reduces seasonal variations in ground resistance. Additionally, the concrete provides physical protection to the electrode, preventing corrosion and mechanical damage. While a larger conductor might seem like it would improve the performance of the grounding electrode, the benefits are often marginal in the case of a concrete encased electrode. The limiting factor is typically the impedance of the earth surrounding the electrode, rather than the conductor itself. Increasing the conductor size beyond number 4 AWG copper doesn't significantly reduce the overall impedance of the grounding path. Furthermore, using a larger conductor can introduce additional costs and installation challenges without providing a substantial improvement in safety or performance. For example, a larger conductor is more difficult to work with, requires larger connectors, and may be more susceptible to physical damage during installation. It's important to note that the number 4 AWG limitation applies only to the portion of the grounding electrode conductor that serves as the sole connection to the concrete encased electrode. If the grounding electrode conductor also connects to other grounding electrodes, such as ground rods or metal water pipes, the size of the conductor may need to be increased based on the requirements of Table 250.66. Additionally, if the concrete encased electrode is used as part of a lightning protection system, a larger conductor may be required to handle the high surge currents associated with lightning strikes. In such cases, the requirements of the lightning protection standard, such as NFPA 780, should be followed. It is important to consult with a qualified electrical engineer or inspector to determine the appropriate size of the grounding electrode conductor for a specific installation. They can assess the specific conditions and requirements and ensure that the grounding system complies with all applicable codes and standards. In summary, the number 4 AWG limitation on the size of the grounding electrode conductor for concrete encased electrodes is based on a combination of factors, including the effectiveness of the electrode itself, the impedance of the earth, and cost considerations. While a larger conductor might seem beneficial, it doesn't typically provide a significant improvement in performance and can introduce additional costs and installation challenges. By understanding these factors, electrical professionals can make informed decisions about grounding system design and ensure the safety and reliability of electrical installations. The NEC provides specific requirements for grounding electrode conductors based on the type of grounding electrode used and the size of the service entrance conductors. Section 250.66 dictates the sizing, but there's an exception for concrete encased electrodes. According to 250.66 subparagraph A, if the grounding electrode conductor is connected to a concrete encased electrode as described in 250.52 subparagraph A.3, that portion of the conductor that is the sole connection to the concrete encased electrode is not required to be larger than number 4 AWG copper wire. This recognizes the effectiveness of concrete encased electrodes. These electrodes have a large surface area in contact with the earth, providing a stable and reliable ground connection. The concrete encasement helps maintain consistent moisture levels, improving conductivity. The code recognizes this and allows for a reduced conductor size, since the earth surrounding the electrode is often the limiting factor in impedance. Increasing conductor size beyond number 4 AWG doesn't significantly reduce impedance. Using a larger conductor can increase costs and installation challenges without substantially improving safety or performance. A larger conductor is harder to work with, requires larger connectors, and may be more susceptible to damage. This number 4 AWG limitation applies only to the portion of the grounding electrode conductor solely connected to the concrete encased electrode. If the grounding electrode conductor also connects to other grounding electrodes like ground rod or metal water pipes, the conductor size may need to be increased based on table 250.66. If the concrete encased electrode is part of a lightning protection system, a larger conductor may be needed per NFPA 780 to handle surge current. Consult with a qualified electrical engineer or inspector to determine the appropriate grounding electrode conductor size for your specific installation to ensure compliance with codes and standards. The NEC provides clear guidelines for grounding electrode conductors. The limitation on conductor size for concrete encased electrodes stems from the fact that these electrodes are inherently effective due to their large surface area and the stable moisture content provided by the concrete. The concrete helps maintain a consistent moisture level around the electrode, which improves its conductivity and reduces seasonal variations in ground resistance. The primary purpose of a grounding electrode system is to provide a low impedance path for fault current to return to the source. This facilitates the quick operation of overcurrent protective devices, minimizing the risk of electrical shock and equipment damage. A larger conductor doesn't always translate to a significant improvement in the overall grounding system performance, particularly with concrete encased electrodes. The limiting factor is often the impedance of the surrounding earth. Increasing the conductor size beyond a certain point, typically number 4 AWG copper, doesn't substantially reduce the overall impedance of the grounding path. There are practical considerations as well. Larger conductors are more expensive, more difficult to install, and require larger connectors. The NEC balances performance requirements with cost effectiveness and practicality. The number 4 AWG limitation is a compromise that provides adequate grounding performance without unnecessary expense or installation complexity. This limitation only applies to the portion of the grounding electrode conductor that is the sole connection to the concrete encased electrode. If the grounding electrode conductor connects to other types of grounding electrodes, such as ground rods or metal water pipes, the size of the conductor may need to be increased according to table 250.66. The requirements of the lightning protection standard should be followed if the concrete encased electrode is used as part of a lightning protection system. The NEC provides specific requirements for grounding electrode conductors, balancing performance costs and practicality. The limitation on conductor size for concrete encased electrodes reflects their inherent effectiveness and the characteristics of earth impedance.